You know, mothers are awesome, and so is Mechanical Advantage. See, your ma is great, and so is Mechanical Advantage. So MA is Mechanical Advantage. Today we're going to talk about a new way to find out the mechanical advantage of a machine. But let's first talk about the old way. All right. So here's some machine. We don't know what it is, so that's why the cloud. It's a machine. But one thing we do know from the problem is if you provide an input of 50 newtons, the output side of your machine puts out 500 newtons. And so this is the way we've talked about mechanical advantage. So mechanical advantage is the ratio of the output force, what comes out of your machine, divided by the input force, which is the force you have to put in. And here we get 500 newtons out when you put in 50 newtons, and 50 divided by 5 is 10. So this is basically, ultimately, what mechanical advantage is all about. Getting 98% of the time, we'll talk about the 2% later, but getting more force out than when you put in, and that ratio of how much more force you get out divided by versus what you put in is called mechanical advantage, and this is one way to get it, and this ultimately is what it's all about. But here's a problem. It's a problem, is you need to know the forces. And when you go into a machine store to say, look, I want to buy a machine, and you're interested in getting a mechanical advantage of 10 or 20 or 500, whatever, you've got to bring in some force measuring device. And who has those hanging around? Well, I do because I teach physics, but most people don't. Okay, so what we want to do is we want to find a way to get the mechanical advantage of a machine that doesn't involve taking spring scales and force sensors. We want to be able to just kind of look at a machine, maybe take a couple of easy measurements, and then find out what the mechanical advantage of that machine is. So that's going to be our new way. Okay, so let's look at this machine. Again, I don't know what it is, but I do know there's a lever. So this is the input side, and this is the output side of your machine. And let's draw your hand. And I've been known as a world-renowned hand artist. Here you go. There's your hand. Yep, there you go. And you notice that, so you're in this machine store, and you just play around with this machine. No force sensors, but you do have a yardstick or a tape measure. And you notice that when you pull down on this lever, let's just say you pull down on it that far, this little platform thing goes up by this amount. Okay, so you pull down that much. We don't really need that top arrow. But this is the input distance. And then when you do that, you notice the platform goes up by that much, and I'm going to call that the output distance. Okay, and let's go ahead, and since we're talking about it, let's go ahead and get some abbreviations because that's way too many letters to write. So this is going to be abbreviated DN. This is the distance through which you have to pull or push to make the output side of your machine do something. And if this is DN for input distance, then output distance, you got it, is going to be D out. So these are easy to measure, right? You just bring in a little meter stick, yardstick, anything, you can use your fingers, whatever. And so I want to be able to get a mechanical advantage of a machine by simply measuring these. And I want to know, is that possible? And if it's possible, how do you do it? Well, here's how you do it. And it is possible. Otherwise, we wouldn't be talking about it. Okay, so it all comes from this very fundamental absolute rule that best case scenario, the work, remember W is work, the work that comes out of a machine, best case scenario, will never exceed the input the work that you put into a machine. If you want your machine to do work, you got to do work on the machine. And best case scenario, and that means like no friction, no squeaking, no making noise, no vibration. Best case scenario, at least in theory, the work that comes out of your machine could be, in theory, as much as the input work you put in, but never anymore. Okay, so let's get going here. All right, well, what is work? Work is force times the distance. And this is force times the distance. But you can see, well, which one is which? Well, this is force out times distance out. This is what's coming out of your machine. So there will be a force out coming out of your machine. And you are putting in a force in. Okay, and so this is the in. dn, yes, dn. You can do it. All right. So now, do a little algebra. And basically what I'm going to do is I'm going to divide both sides by Fn. And I'm going to divide both sides by d out. Let's just do that now. Okay, so let's just do it. All right, so I'm going to divide both sides by Fn. I can do that in algebra, right? Do anything you want to both sides. And then I'm going to divide both sides by d out. I'm just combining it one time. Looks kind of crazy. But that, okay, let me do color because that equals 1, so it disappears. And this Fn over Fn equals 1, so that disappears. So what am I left with? And you're going to go, well, I don't know. Well, let's see. F out over Fn equals dn over d out. Okay, well, what is this? What is F out over F? There. No, actually, I should circle that. Mechanical advantage. So here is generally the best way to get the mechanical advantage of a machine. Mechanical advantage equals, okay, you got to take two measurements. You got to measure D in and you got to measure D out. Let's suppose in this case, go back to this example, let's suppose that in this case you pull down 1 meter, a little over 3 feet. So this is a big lever. And this thing came up, I'm not going to make it as big as it looks like. So, well, let's just say it came up 0.2 meters. So actually it comes up a pretty big amount itself. Okay, what would be the mechanical advantage of this machine? You don't know the input force, you don't know the output force, but yet you can still know the mechanical advantage of the machine, at least best case. All right, well, what is our D in? You pull down with 1 meter. Nothing about force, this is all about distance. You pull down with 1 meter, and when you did that, the output part of your machine rose up by 0.2 meters. So the meters cancel, so no units. So what is 1 divided by 0.2? Well, it turns out to be 5. Okay, so without knowing any force, this is our new way, and this is the most typical way to get mechanical advantage. Okay, so this machine has a mechanical advantage. Best case, maybe we'll talk about what happens if you start actually dealing with friction. We'll see. The best case is 5. So if let's do that. If I pull down with 5, if I get 5 times more force out of my machine than I put in. So if you were to pull down with 10 pounds of force, that's like 2 newtons. No, sorry, I'm going backwards. That's like 45 newtons. How much force would come out of this machine? Well, you would get 5 times what you put in. So you would actually get 50 pounds of force coming out of your machine. There's mechanical advantage.